So I'm going to introduce the Haxe-Func projects that transpile Haxe code into Func for smart contracts in Tor network. Key features. It's essentially trying to leverage everything Haxe have from static typing, LSP, so code completion is very amazing, and also type safety and all that kind of stuff makes like the confidence level when we write our smart contract is higher than normal. This is the version that we are aiming to reach, but for now we have simpler version. For example, this code actually compiling into this function already right now. There's an instruction for you to getting started and try everything by yourself. But I will make a tour, introduce you guys how it works. So in my screen, you see this file is the most important of the transpiler. It's transpile Haxe AST, const, var, local, like idents. In Haxe code, everything is blocks. So we transpile block by block, Haxe block into Func blocks, and Haxe like expose very powerful system for us to manipulate this kind of AST, and even further when the users they write smart contract in Haxe-Func, for example, they can use the macro system that Haxe provide. They have a chance to mutate, transform the original AST that they write into another version before actually send it into Haxe-Func, and Haxe-Func will generate Func code for us to deploy in Tor networks, for example. So it's very powerful. Not only provide like static typing, but a lot of other things that Haxe have. So now this is our forgot about this one. This is okay. So now we are going to try out to see what we have. Let me open this one as a reference so that I can follow. Right now we have to put this line, the kind of boilerplate code. I need to fix that to actually make it work with the main function. For most of the Haxe program, common way is that we have a class named main, and under the main class we have a function name also main. So this is entry points of our program equivalent to main of the Func. So in here, for example, I create a counter with the value 0. So by default, Haxe will have type inference, so it know that counter is an int. So let's try to create Func code into that right hand side. Is the code that actually generated by this Haxe source. So in here, it's actually know that we are going to work with the int of Func here. How about bool? I'll say true, and compile again. We actually don't have Boolean in Func, so the transpiler is smart enough to actually understand that we are right in here. We know it's bool, and we can do like all kind of operations with bool, like we are doing in Haxe normally. But when it's transpiled into Func, it's smart enough to keep the presentation in the right type. Also, with string, we can have sample. I copy this line into. So it is smart enough to handle string. It's like, how about float is 10. This is totally valid in Haxe. We have float type in Haxe, but unfortunately we don't have it in Func. we can only work with ints. So if we trying to compile, it will say functions does not allow log type, so you cannot use it. Consider use int instead. So not everything from Haxe we can use in Func. It's like a subset of features that is available in Func, and the transpiler is smart enough to know and use only things that is valid and transformable into Func. So we cannot use that one. Further, you can like one class will be transpiled into one file. In our case, class main will be main.func. We can have another class. It will generate another. Okay, let's try. Class, for example, contract. Jetstone. Actually, this is just a proof concept. We don't have a Jetstone interface yet, and we don't have implementation of the things like interface already. So let's just check if it creates. Okay, we can do main, or actually we can do other things that would be no problem with we have another name. But okay, let's keep it this name, and I will do something very interesting. Untype. We can actually write unsafe function code. That's everything inside our method here, is like our string here will be directly print. This is function command. So everything here will be print directly into generated code without any problem. So we can have sometimes we want to transpile Haxe-SD into function, but also case when we need to work very low level, we have a way to interact with low level function this way. Actually, you can do, because it's just like, okay, I will do it init instead. And init will return a string. So in the case, you need to return. No, yeah, no, try that. So it's actually generate the Jetstone.func for us right here. So if you open that main function, and under the main function we have what we say. This is a function. This is function command. That's it. This is what we want to have. So it actually prints anything we put into the unsafe code here into our generated function. So we have Jetstone and main. Okay, back to let's back to the main class. In the same class, if we create different methods, for example, we have another static functions at A and B, both type of links, and then we return A plus B. So the nice thing here is that Haxe is very powerful at type inference and select typing. So we know that at have the return type of int, even we don't clarify it. So it will be very useful when we write smart contracts with Haxe programming language. We have higher level of confidence. We don't have to think so much if we are doing something wrong. We cannot, for example, we cannot mix the type. We have an int, and we're trying to concat it with integers, with a string, and that would be warned by the compiler, by Haxe, in the time we write already, and refactor, code refactor, things like that. With the LSP, things like code refactoring with LSP, also very useful. So now we're trying to call, we have added is at. So we do counter and 10, for example. Let's see. So the signature of the function say it will return an int. So we know at is an in here by the LSP. Of course we can do things like this to make it easier to understand and very declarative, but we can rely on the type inference. So in that case, when it generates the function code, it will infer the right type for us. What else? We can also have public, static, var, for example, global counter equal to 10. Same thing here. We have type inference, so it knows that global counter is actually an integer. Okay, make it 0, and I will change it here. So we add the global counter and the counter together. Compile it again. See it. Yep. So we have global counter is 0. It will be smart enough to know. Actually, we cannot do like this in function. It's not valid. So if we initialize in a Haxe way, it's smart enough to actually create a global variable and then assign it inside the main function. In case like we don't want to initialize it, we need to, in that case, we need to have type, because there's no type inference. So we need to know what type it is. In the case we say, okay, we want to use ints. And now, instead of automatically generate global counter equal to something here, we can ourselves control where we want to initialize the variable, the global variable, like this. So we completely have the flexibility to actually control where we want to initialize and leverage syntactic sugar from Haxe, but it's also quite flexible for us to control every aspect of the generated program that we want to do. So I click OK. I think that would be fine to do this for me. So I will initialize it this way and let the syntactic sugar figure it out where to assign the global counter variable. And until now, that is what I have. There would be more things to add, like interface, inheritance, more type. Now we have very essential type, int for number, boolean, actually int, slice for string base. We need to have another type. What I remember, we have had 6 or 7 type, primitive type, and also the standard library, which is also covered by the library that we are used to create Haxe-Func. With that standard library in place, we can try to use everything we have from Func standard library in code with all the code completion, type, inference, standard typing, inheritance, unit testing, things that we don't have easily in Func. I think that's it. You can actually went through the repo and Haxe-Func. And try search in Google. I believe you can find it. It has essential instruction for you to getting started and write your code that transpire already into Func. This is still very early. What we currently have is a proof of concept that everything at the essential level start connecting. We can create a simple Func program with our Haxe code. There are absolutely a lot of things to be done to make it more stable, but we already have a good backbone to proceed further. So that's it. We went through on the essential things and know how we can construct a very simple program in Haxe that compile into function. The development is still under progress. Will be more complete when you come back next time. See you later.